example, we're now looking at an ice block melting and forming a circular puddle. So there's a little circle. And the puddle is actually increasing in size. So the radius of that puddle is increasing. And the particular problem we're looking at here has the radius of the puddle increases at a rate of 3 centimetres per metre. And the question's asking when its radius is 2 centimetres, so that's a set value, find the rate at which the area of the puddle is increasing. And you can see here, this is just like the previous example, it doesn't really say what it's increasing with respect to, so that would imply that it's with respect to time. So I can see straight away that I need the change in area with respect to a change in time when the radius equals 2. And I'm just going to use quite standard things for radius and area. So I'm going to let radius be r. And radius you can see is given in centimetres. So they're the units. I'm going to need area. I'm going to let area equal centimetres squared. What I should also say is I'll let that be A for area. So I'm just using kind of standard notation. And the other thing that I can see here is I've got some representation of time. So I'm going to let time be t, and that's going to be given in minutes this time rather than seconds. So I've got a few things there. Now I know what I need to get is dA dt. I can see in the question that I have been given centimetres per minute. Centimetres per minute implies that this is a rate of change of the radius with respect to time, because it's in minutes, and I know that that is equal to 3 centimetres per minute. So I know dr dt, so I'll just put a thing around that, and I know what I need, which is in the green up here. So the only other thing that I need to do now is think about what else do I need to help me with this. Now I've got a dt here and a dt here, so that's good. I obviously need some kind of relationship between I should say, and also r, because I need to get a dr in there. And what I know is I'm dealing with a circle, so for a circle, we know that area of a circle is pi r squared, and that would be in centimetres squared as well. So if I want to have a dr in there, it makes sense to differentiate both sides of that expression for area with respect to r. So I'll get dA dr equals the derivative of pi r squared, which is 2 pi r. And what you want to look for is what the rate of change is with respect to its area, so centimetres squared, over radius, which is centimetres. And you can see that with the units, your centimetres squared will cancel with centimetres, so you'll end up with dA dr equals 2 pi r centimetres. And it's interesting, if you look at that, the derivative of the area formula is actually the formula for circumference. So now you can see that you have both things that you need, the dt and also the dA. And the nice thing with this expression is that the dA is already on the top. So I know that I need dA dt. Well, I can get that by taking dA dr, using chain rule, and multiplying that expression with dr dt. What will happen is the dr on the top and the dr on the bottom will cancel to give me the dA over dt that I need. So now all we're going to do is find dA dt by multiplying dA dr, which is 2 pi r, times dr dt, which is 3. And what we get there is 6 pi r. And the units that you should have there, we know this would be, and I'll just put this on the next line actually, so we've got a bit of room. This would be centimetres per minute over here. And this expression here would be centimetres. So you'd actually have centimetres squared per minute. And check that that makes sense with what you're working with. So you can see here that you have area and time. Well, area is centimetres squared, and the centimetres come from here and also from here. And then you've got the per minute that comes from the dr dt. So that makes sense. I'm just going to move this out and actually put those values here so you can see them. I'm really quite particular about the use of the units because I think it's a really good check to see if you're actually doing the right thing. There we go. So now you can see where those different units come from. Let's get rid of that one. So Now what you want to do is really look back and read your question again. Make sure that you've answered what you needed. We needed dA dt. Well, that's cool, we have that. Oh, but we also needed it when the radius was equal to 2. So let's put that underneath here to finish off the question. So we have when the radius equals 2, dA dt equals 6 pi times the radius, which is 2. So that's 12 pi, and it's centimetres squared per minute. So that means that the radius is 2 centimetres for that particular circle. The rate at which the area of the puddle is increasing would be 12 pi centimetres squared per minute. So that's the rate of area increasing with respect to time for this question. I'd leave it in that form as well, so don't take it into a decimal, leave it in exact form.